Welcome back, everyone. So this should be the first lesson of Unit 3, where we are taking a look at functions today, specifically functions that don't return anything. Return functions are completely different. We'll say that for the next one. In this case, we're doing functions that don't return, and that means that they're usually going to output something. Now, an output for us has been a print statement. Other methods of output, depending on what you're doing, can be a number of different things. It could be making a motor turn on a robot. It could be drawing something on a screen if you're making a game. It could be updating a label if you're making an app. So there's so many different things that these types of functions can be used for, but it's also going to give you a good basic understanding for the next section of lessons. So let's get started. I'm going to make a new file. I'm going to call it functions.py. So now I have a new file called functions.py, and I'm going to make my first function. Whenever you are making a Python file, you want to follow the following format. You want to do imports first, which we have none on this. We have none. Then you want to do function definitions. The reason why you do function definitions now and not later is because the computer will then know what this function is. So if you use it later or call it later, which I'll show you what that means, the computer already knows what it is. And I'm just going to leave a space there because that's where my function definitions are. And then we'll call this main code. Okay? And our main code is usually declaring variables, process, and then output. All right? So I'm going to leave that down there, and I'm going to make our first function. I'm going to have it count to 10. And to do this, I'm going to use a for loop for I in range. Oh, didn't mean to do the star. 1 to 11. But remember, it doesn't include the last number. Print I. Okay. So now the computer knows that every time I write the command count to 10, it will then run a function that will print out 1 all the way up to 10. So let's do a print statement here just to see where it starts. So we'll call this program start. I realize I need to move this, so I'm just going to cut it and paste it up here. There we go. Because this is my main code, I want to keep it separate from my function definitions. Then I'm going to count to 10. I have to add parentheses at the end because it's a function. We have to tell it that it is a function, not a variable. So the computer knows what you're actually referencing. This is where you want to be careful of your naming scheme as well, because you don't want to name a function the same as a variable because that can get very confusing to read. So be very careful on how you name things. And then we'll just say the function has ended. Okay. So now I'm going to save. Every time the computer gets to here, it's going to jump up into this code and run through it. And I'm going to use the debugger to demonstrate this. So to use the debugger, you can select debugger here. So debug Python file. And I'm at my breakpoint. So now the computer sees count to 10. And the computer has already been told the definition of count to 10 up here. This is why it has to happen first. So if I go step into, it actually goes into the function above. So now we're seeing code jump around a lot more than as if it was in a loop, because it's going to skip this to go back up, and it's not going to do this again because it's not part of the function. So it only printed program start, and if I keep doing step into, it's going to print what the value of I is, which currently it's 1. We can see in our inspector on the left here. And I can keep stepping into, It's just going to loop through. I'm just going to hit continue because we kind of get the idea. It's going to print all the way to 10. And then once it's done, it jumps back to here and continues on. So it printed 10. That would have been the last number. Went back to here. Computer knew it was done, so then it starts reading this line of code here. So print the function has ended, and that's where we can see the function has ended. Okay, so now we kind of know how a function works. There's a little bit more, because this is kind of, like, we can kind of use this. It's not super useful, but I could do count to x. Okay. And now I can tell the computer to count to a number. So instead of just doing 10, I could do 100, right? So I'm not going to use the breakpoint for this. So what happens here in this instance? Count to 100. X up here is going to take on the value of 100. And I'm just going to do x plus 1. Because remember, it doesn't include the value here. It didn't include 11 when it was 11. So we want to go x plus 1. So it goes all the way to x, but doesn't exceed it. All right. I'm going to save. I'm going to run. And it went all the way to 100. So now I can just change this number and get a different answer. Pretty useful, but you can make this even more involved. I could have a function, or not a function, a variable use a function. Or a function use a variable. So if I had a number and it was equal to an int input, enter a number, and a \n, so it goes to the next line. And I had count to number. Now, whatever I enter here gets stored in this variable, like we've seen a couple dozen times. Then it's going to go in here. X is going to take on the value of number. Okay? It's going to take whatever the value is inside number, and X is going to become that so that it can run this. That means that it is completely modifiable. So if I run it again, it's going to ask me to enter a number. If I enter 17, should count up to 17 and stop. There we go. We can see it counted up to 17. You know what else I can do? I could do count 2 again, and then 3. So what's going to happen is x takes on, x from here, takes on the value of number, so whatever I type in, then it's going to take on the value of 3 and then run this function again. So I'm going to run this, enter a number, I'm going to enter 17. It counted up to 17, then it counted up to 3. Or, instead of just writing it twice, I could while number is while true, and then indent this, and then if number is less than 0, break. So now I've put this in an infinite loop. It will not stop until the number I enter is less than or equal to 0. Let's start with that. And it will always count up to the number I enter. And it will just do this repeatedly. So now I could enter 2. It's going to count 1, 2. Now I can enter another number, 5. It's going to count up to 5 for me. Now I could enter 77. Okay, it's going to count all the way up to 77. I can scroll up and check all the numbers. Okay, kind of useful. And if I want to exit, -1. Function has ended. So there we go. It will loop and keep using this function. Now, the power of functions comes from the ability to break up your code from complex ideas into simple steps. This function is fairly simple. It just counts from 1 to whatever number you give it. Let's make a new function that does a calculation for us. And it's going to be a simple calculation just to kind of teach you the idea. And then you can take this idea and make countless other functions. So in this case, I have sum of x and y, and you can use x and y. For functions, you can use parameters or arguments. These are called parameters in here when they're in the brackets. and you can reuse them because x only exists inside this function, so x and y will only exist inside of the sum function. So the x in count2 is going to be different from the x in sum, and they don't interact with each other, so we're safe. Now, you can rename them something different to avoid this confusion. It's not a huge deal. Most programmers will understand the range in which x is actually used. So in this case, I just want to print the sum of the two numbers. So I'm going to print the sum is, and then x plus y. Make sure to add some spaces in there, make it look nice. So now I have a new function called sum. Now I can give sum any number I want, and you know what? I'm just going to comment out this code here. Actually, no, let's just comment all of this. Comment it out. Perfect. Okay, so now I can call the sum function, and I can give it two different numbers. Any two numbers. I could give it 3.14 and 2. And we should get 5.14. If I run it, the sum is 5.14. And yeah, we'll see a bunch of decimals here. If you want to learn more about why that happens, I suggest taking computer science all the way through to grade 12 because we actually dive into that. For this year, don't worry about it. It's just a rounding error. Computers aren't the greatest with decimals. Anyway, so we can use sum for this. We could use two inputs. I could have number 1 is equal to an int input. Enter the first number, and a \n. And you know what I'm going to do? I'm going to copy it, and then I'm going to paste it, and then I'm going to change this from number 1 to number 2. And we can say the second number. Perfect. And now I can change these to number 1, comma, number 2. And if you get really creative with this, say you want to do a bunch of questions for homework, and you made a function that does a really good calculation, you can use this to check your answers. You can actually use this for physics as well. So that's something else that you can use this for. Granted, you're probably not doing sum because that's usually something that you focus on in lower grades, and you're in grade 10 at this point. So this wouldn't be particularly useful, but if I have 3 and 4, it adds it, and now it asks me to enter my next two numbers, 9 and 8, and we get 17. So we can see that it's working and it's repeating. I don't have an exit case, so I actually have to just end the program here. You should always have an exit case, so I'll say if number 1 is equal to 0 and number 2 is equal to 0. Break. There we go. Whoops. Perfect. And that's pretty much it. Now you know about parameters. That's those things that go inside the brackets. Remember, number 1 goes in for x, number 2 goes in for y. Order matters in this case. So x will take on the first things that's passed into the sum function. Y will take on the second value of what's passed into the sum function. And then you can use them however you'd like. You can also pass in string instead of just numbers. But that's left for you to discover in your exercises. And I will see you in the next one.